In this partner collaborated video, Sharon Richard from IBM and I will show how data scientists can leverage Red Hat and IBM technologies to make decisions based on machine learning. In this video, we will discuss the benefits of running machine learning modeling on OpenShift. Then Sharon will demo how e-commerce retailers can understand customers' buying behavior using machine learning with Cloud Pak for data on OpenShift. The convergence of compute power provided by the cloud, whether it is GPUs or TPUs, then the advancements made in machine learning libraries, and the access to big data have all made machine learning based AI decisions a reality as of today itself. Some of the advantages of running machine learning modeling on OpenShift are data scientists can just focus on the data and the machine learning model. They don't have to worry about the underlying infrastructure or pipeline creation needed for repeatability. It's all taken care of. With OpenShift, data scientists can execute their models leveraging the compute resources offered by the cloud or run it against the on-prem data. The machine learning models generated are portable across public clouds or on-prem. It is simpler to exploit NVIDIA GPU-enabled hardware infrastructure or integrate with open source libraries like Jupyter or TensorFlow or PyTorch. According to a recent Forrester report on MLOps using OpenShift, data scientists can save a significant amount of time and also realize infrastructure savings when running on OpenShift. I have an OpenShift 4.10 cluster running on AWS. I'll navigate to Operator Hub. I'll search for Cloud Pak for data. Cloud Pak for data can be installed as an operator on OpenShift. These are the list of services that come with Cloud Pak for data, including Watson Studio, Watson Machine Learning, and so on. In case Cloud Pak for data does not get populated in your operator catalog, you can just add this YAML. I'll now hand it over to Sharon for the rest of the demo.
You will see how to build a binary classification model that assesses the likelihood that a customer of an outdoor equipment company will buy a tent. This video uses a dataset called Go Sales, which you'll find in the gallery. View the dataset. The feature columns are gender, age, marital status, and profession, and contain the attributes on which the machine learning model will base predictions. The label columns are Is Tent, Product Line, and Purchase Amounts, and contain historical outcomes that the models could be trained to predict. Add this dataset to the machine learning project, and then go to the project. You'll find the gosales.csv file with your other data assets. Add to the project an Auto AI experiment. This project already has the Watson Machine Learning Service associated. If you haven't done that yet, first watch the video showing how to run an Auto AI experiment based on a sample. Just provide a name for the experiment and then click Create. The Auto AI Experiment Builder displays. You first need to load the training data. In this case, the dataset will be from the project. Select the Go Sales CSV file from the list. This isn't a time series forecast, so select No for that option. Auto AI reads the dataset and lists the columns found in the dataset. Since you want the model to predict the likelihood that a given customer will purchase a tent, select Is Tent as the column to predict. Now run the experiment. Auto AI first loads the dataset, then splits the data into training data and holdout data. Then wait as the pipeline leaderboard fills in. Back on the Experiment Summary tab, expand a pipeline to view the model evaluation measures and ROC curve. After training, the holdout data is used for the resulting pipeline model evaluation and computation of performance information, such as ROC curves and confusion matrices. Here you can also view the model information, feature summary, confusion matrix, and precision recall. This pipeline had the highest ranking, so you can save this as a machine learning model. Just accept the defaults and save the model. Now that you've trained the model, you're ready to view the model and deploy it. The Overview tab shows a model summary and the input schema. To deploy the model, you'll need to promote it to a deployment space. Select a deployment space from the list. Check the option to go to the model in the space and promote the model. Here's the model you just created, which you can now deploy. In this case, it will be an online deployment. Just provide a name for the deployment and click Create. Then wait while the model is deployed. When the model deployment is complete, view the deployment. On the AP Reference tab, you'll find the scoring endpoint for future reference. You'll also find code snippets for various programming languages to utilize this deployment from your application. On the Test tab, you can test the model prediction. You can either enter test input data or paste JSON input data and click Predict. This shows that there's a very high probability that the first customer will buy a tent, and a very high probability that the second customer will not buy a tent.
Thanks for watching. Please feel free to check out some of the other videos in our YouTube channel.